Okay, so L'Hopital's rule. All right, the first thing to know is if we are trying to take the limit of a function as x approaches some value, which I'll call c, and we have some function on the top and some function on the bottom, and we get either 0 over 0 or infinity over infinity, negative infinity over negative infinity, any combinations of signs with the infinities, really, this is indeterminate. And what that means is it doesn't tell us any information about which function grows faster. So what we need to do is, like you said, some extra work. And I think something that's not clearly pointed out in the textbook is, yeah, it says this, but when to not use L'Hopital's. If you take this limit above this limit right here, and you get like 1 over 0, or like infinity over 2, those aren't indeterminate, right? These actually end up being different values depending on what the limit is. But they're not indeterminate, depending on limit. Not indeterminate. So yeah, if that happens, you don't use L'Hopital's rule. Okay, so let's do an example. Okay, the first example is a really simple one. It's going to demonstrate, this is just a very basic case, so there's nothing fancy here. So if we take this limit, we basically plug in 0 over 0, sine of 0. If we look at our, here's our 0, pi over 2, pi, and 3 pi over 2. This is like comma 2 pi. Sine at 0 is going to be the x value, so, or I'm sorry, the y value, and the y value at this point at 1, 0 is 0. So we have 0 over 0, and that is indeterminate. So let's use L'Hopital's. So we take the derivative and we get cosine of x over 1, and now we take that new limit. Cosine of 0 over 1. We look at cosine is the x value, so we look at angle 0 and we see, okay, it's 1. 1 over 1, so that means our answer is 1, and that's all you have to do. So now, let's look at a little bit more of a tricky case. Okay, let's say we have, which part of the screen is recording? Oh, okay, I see. Cool. All right, let's say we have limit as x approaches infinity this time of e to the x over x squared. Now again, if we actually plug that in, we're going to get e to the infinity over infinity, which is infinity over infinity. And that is, whoops, indeterminate. So let's apply L'Hopital's. So we take the derivative of the top and the bottom separately. Remember, not quotient rule. We just do it separately. And we get e to the x over 2x. And if we do this again, we get e to the infinity over 2 times infinity. It's the same thing. But if you look, notice infinity over infinity. So we can use L'Hopital's again. So we take the derivative of the top and bottom again, and we get e to the x over 2. This looks promising. E to the infinity over 2, infinity over 2. So our answer is just infinity, right? Because if we have infinity divided by some small number, it's still infinity. And if we notice, we don't need to do this again, right? Because we have a limit. It's not indeterminate. We can get information from it. So that's a little bit more of a tricky case. Now I'm going to go over a different, whoops, let me delete this. Oh, I can't delete this layer.